Dart School presents multiplication of fractions. To multiply two or more fractions, the simplest rule is to multiply the numerators together and multiply the denominators together and have the answer as the product of the numerators on the top and the product of the denominators on the bottom. So for example, if you were to multiply the fraction 2/3 with the fraction 7/9, you would do 2 times 7, which is 14 on the top, and 3 times 9, which is 27 on the bottom. Similarly, to multiply 3/4 with 1/2 with 3/5, you would do a 3 times 1 times 3 on the top, that's a 9 on the top, over 4 times 2, that's 8, times 5, that's a 40 on the bottom. However, it makes sense to pick factors from the numerator and the denominator side that have got GCFs that are larger than 1 and then divide them with the GCF before multiplying them out. Consider the multiplication of the fraction 2/3 with the fraction 3/4. Well, you could do 2 times 3 is equal to 6 on the top and 3 times 4 is equal to 12 on the bottom, and then go on to simplify this fraction, which eventually gives you 1/2. But then because the commutative property works with multiplication, which means 2 times 3 is the same as 3 times 2, you could pretty much interchange the factors in a multiplication sentence without changing the problem itself. So this can be written as 3 times 2 on the top in place of 2 times 3, and then 3 times 4 on the bottom. And then this one, this part, if you consider that as one fraction, its value is equal to 1 because 3/3 is equal to 1. The idea is you could actually reduce any numerator with any denominator. They don't have to come from the same fraction in the original multiplication sentence. So you could cross off the 3 on the top with the 3 on the bottom like this, and similarly reduce this 2/4, divide 2 with 2 and 4 with 2. So in the actual problem, you could have divided 2 with 2 and this 4 with 2, even though they are not a part of the same fraction. So the answer is going to be 1 times, this is a 1, 4 divided by 2 is 2, 1/2. And the real advantage of doing it this way is that you are actually reducing the numbers or making them smaller before you are multiplying them. So you are saving yourself some time by not having to multiply numbers, and then if your teacher wants you to write down the answer in the simplest form, you are also saving some time by not having to reduce a larger fraction to the final answer. Let's look at another example. Let's say you want to multiply the fraction 3/8 with 16/15. Now imagine multiplying 3 with 16 and then 8 with 15, getting two big numbers, one on the top and one on the bottom, and then having to simplify it. Why not instead divide this 8 with 8 and this 16 with 8 and this 3 with 3 and this 15 with 3. So 3/3 is 1 over 8/8 is another 1 times 16/8 is 2 and 15/3 is 5. So the answer is 2/5. Easily done, right? And then how do we multiply mixed numbers together? For example, 2 and 1/2 multiplied with 3 and 4/5. Change each one of them to their corresponding improper fractions and do the multiplication. So 2 times 2 is 4, 4 plus 1 is 5, so this is 5 seconds, times 3 times 5 is 15, plus 4 is 19 on the top and a 5 on the bottom. Before you multiply, cross off the 5 and the 5, so this is equal to 19 seconds, which is nothing but 9 and 1/2.